Okay, here we have a, this is section 8.1, question E19, and we have an actual population proportion. So you'll notice that many of the questions we've been dealing with had a p hat, like this, which is an estimate. That's a sample estimate of the population. Whereas here, this 0.55 is something different. It's the actual parameter, the actual population proportion. And we have 70 different researchers conducting independent random samples, studies with independent random samples of size 30. So each of these 70 researchers has their own sample of size 30. Each one constructs a 95% confidence interval based on the value of p from his or her sample. For example, maybe researcher 1 gets a sample of size 30, calculates that the proportion of whatever they're studying is 0.52. How many of the resulting, and then creates a 90% confidence interval around that, like we did in P2, the video P2. How many of those confidence intervals would you expect to include the population proportion P of 0.55? So again, they're going to get an estimate for the population proportion. Say they get a 0.52, and then they're also going to create a confidence interval around that. So you may remember we did that here where we created a confidence interval. This was the pet owners who were going to dress up their pet. And we created a lower and upper estimate by going a certain number of standard deviations to the left and right of the estimate. So the question is, how many of those confidence intervals actually catch the real population P? Because not necessarily all of them will. In fact, we wouldn't expect all of them to. Because we're 90% confident, what that tells us is, on average, 90% of the time when we go through this process where we're selecting random samples, calculating a proportion, getting this confidence interval, 90% of the time we will catch the true population proportion. So since we have 70 researchers, 90% of them, on average, we would expect, so 0.9 times 70 would give us 63 of these researchers in their interval would hopefully get that proportion 0.55, assuming again that the sample really was random and there wasn't any bias involved or anything. Now, the funny thing is we can change that. If we change this number to say 0.99, that's going to mean that 69 of the researchers will probably catch the population proportion. We control this confidence interval when we design a study. So if that's true, why wouldn't we just jack this up to make this 99% confidence interval? We're 99% confident. That sounds great. We know that 0.99 of 70, or over 69, so about 69 of these researchers are going to get the true population proportion. What's the downside of that? Well, if you remember question P11, what happens is when we raise the confidence interval, so we raise the level of confidence, the trade-off is our confidence interval gets wider and wider and wider, which is a bad thing. So even though we're very confident, it's not very helpful. I'm 99% confident that the proportion is between 0.2 and 0.8. Well, that's great, you're so confident, but it's not giving us much information because there's a huge difference between 0.2 and 0.8, and we want to be pretty precise. So the trade-off then is the more precise we are, the less confident we are.